Hi, and welcome back to Algebra 2. Today we're going to talk about function notation. This you might remember from Algebra 1 when we talked about different notations to represent functions. All right, so functions are fundamental tools that convert inputs, values of the independent variable, to outputs, values of the dependent variable. There is special notation that is commonly used to show this conversion process. So the y is usually considered the output, the x is considered the input, where the actual f is the rule, which sometimes can be denoted with a g or an h or a different letter. Now don't get this notation mixed up with multiplication. Because of the parentheses, this is function notation. It basically assigns a rule. So taking a look at exercise 1, it says evaluate each of the following given the function definitions and input value. So if you take a look at this, f of x equals x minus 2, and it's telling us to evaluate f of 3. So in other words, what they're telling us here is when x is equal to 3, what is y equal to? So let's go back over here and do a little math and say 5 times 3 take away 2 is 15 take away 2, which is equal to 13. If we take a look at f of negative 2, it's the same idea. Basically, what they're telling us is x is equal to negative 2. So substitute the negative 2 in for x, and you get 5 times negative 2 minus 2, which is negative 10 minus 2, which is negative 12. So you can think about this as an ordered pair. If you're using x and y, for this particular example, the x would be negative 2, the y would be negative 12. For the previous example, the x would be 3 and the y would be 13. If you want to think about it as an ordered pair, that's okay. It kind of means the same thing. So why don't you pause for a minute and give B and C a try and see if you can come up with what G of 3 is and G of 0 is, and the same thing for C. So hopefully you came out with 3 squared plus 4, which is equal to 9 plus 4, which is 13. And then G of 0 is 0 squared plus 4, which is 0 plus 4, which is simply just 4. And when you move over to C, you have 2 raised to the x power. So this is 2 raised to the third power, which is 2 times 2 is 4, times 2 is 8. And this is, be careful with this is going to be 2 to the negative 2 power. Let's see if you remember how to handle negative exponents. A negative exponent up in the numerator means you have 1 over 2 squared. Remember, you move it downstairs and make it positive. So this is the same thing as 1 to the 4th. This could also be evaluated pretty easily in your calculator. Recall that function rules commonly come in 3 forms, like we talked in the last lesson. Equations, like we just went over, graphs, and also tables. The next few exercises will illustrate function notation with these 3 forms. So exercise 2, boiling water at 212 degrees Fahrenheit is left in a room that is 65 degrees Fahrenheit and begins to cool. Temperature readings are taken each hour and are given in the table below. This scenario, the temperature T, is a function of the number of hours H. H then is becoming our independent variable, where T of H is becoming our dependent variable. So it says evaluate T of 2 and T of 6. Well, this isn't so bad, because if we look simply at our table to where x is 2, or h is 2 in this case, you look and you can see this right here. So T of 2 is equal to 104. T of 6, similarly, is going to be 68 if you look over here. Now, B says for what value of h, so this time we're looking for the independent variable, is t of h equal to 76. So if you can think about, this time we're being asked to look for the dependent variable. So where is t of h equal to 76? And it wants us to find the input. So it wants to find for what value of h is t of h equal to 76? Well, if you look down here, you can see t of h is 76 right here, so obviously h is going to be equal to 4. C says, between what two consecutive hours will t of h equal 100? "100" is not here on the t of h, but you can see that it falls between these two numbers, between 85 and 104. So between what two consecutive, remember what consecutive means. It means right after another 1, 2, 5, 6, 9, 10. So between what two consecutive hours will t of h equal 100? Always remembering to annotate your questions. It's very important. So between what 2 hours? H would be between 2 and h is equal to 3. So if you wanted to write that out, you would say t of h equals 100 occurs between 2 and 3 hours. Being able to explain your answer is really almost as important as being able to find the answer. So now we're looking at graphs in exercise 3. The function y equals f of x is defined by the graph shown below. Answer the following questions based on this graph. So evaluate f of negative 1, f of 1, and f of negative 5. I'm going to remind you what this means is when x is negative 1, when x is positive 1, and when x is positive 5. Now on a graph, x is equal to negative 1 is going to be, here's my negative 1. So if you think about x being negative 1, we can think about that being a vertical line right here. So where is x equal to negative 1? It hits the graph at this point right here. So when x is negative 1, y is equal to 0. Similarly now, when x is equal to positive 1, I can't move it, so let's look at positive 1. When x is positive 1, which is right here, we go to the graph. So when x is positive 1, y is going to be 1, 2, 3, 4. Again, thinking about them as ordered pairs. And when x is 5, 1, 2, 3, 4, 5, which is right here, find where it hits the graph, hits the function, at 1, 2, 3, 4, at negative 4. So y is equal to negative 4. So you can think about that as being the point 5, comma, negative 4. B says evaluate f of 0. What special feature on the graph does f of 0 always correspond to? Well, what happens when x is equal to 0? X is equal to 0 right here. So when x is equal to 0, that's the same as our y-axis. So we're looking at this point right here, which is positive 3. So f of 0 is equal to 3. And what does it correspond to? It corresponds to our y-intercept. Now you might just want to take a minute and look at that one more time, maybe rewind it and watch it again, because this gets a little confusing, but it's very important that you understand how function notation works with a graph. All right, coming back now to letter C. I think I brought it up too high because I still need my graph. So C says, what values of x solve the equation f of x equals 0? I'm going to remind you that f of x is the same thing if you remember back in Algebra 1, thinking about y is equal to 0. What special features on the graph does the set of x values that solve f of x equals 0 correspond to? So I'm just going to take a minute and erase some of this so we can see this a little bit easier. I'm reminding you that the line y equals 0 is parallel to the x-axis. It actually is the x-axis. So what values? So now take a look, where does it hit? It hits here, it hits here, and it hits here. So we can say f of x equals 0 when x is equal to, now I've got to go back and look at one more time, negative 1, 1, 2, 3, positive 3, and 1, 2, 3, 7. And what do they correspond to? Sometimes we call them roots, but more commonly they're known as the zeros of the function. So the zeros mean the x values when f of x, or y, is equal to 0. That's a really good card to make for our vocabulary lessons. D says, between what two consecutive integers does the largest solution f of x equals 3 lie? So y equals 3 means we are looking at y equals 3, 1, 2, 3. It's this line right here, and it says the largest. So if you take a look, the largest actually falls between two integers right here, because it crosses here, and then of course it crosses here. So between what two integers? 1, 2, 3, 4, 5, 6, 7, and 8. So when x equals 7 and x equals 8. You can be a little bit more specific with it, and you could say between x equals 7 and x equals 8, that would be the largest solution to f of x equals 3. You might want to pause and take some notes before we move on. Exercise 4. For a function y equals g of x, it is known that g of negative 2 equals 7. Which of the following points must lie on the graph g of x? Well, like I said before, if you consider this to be an ordered pair, the x is negative 2 and the y would be 7. So very easy. This is the nice, easy multiple choice question. So 2 would be the correct answer. Why don't you pause for a minute, try number 5 on your own, and then come back and we'll try and do it together. I actually think number 5 would be a better problem to start our class with. So instead of doing this now, I'm going to do it tomorrow when you come back into class because it's requiring us to use tables and change table plots on our calculator, and doing that in front of you would be a whole lot easier than trying to show you right now. So why don't we stop our lesson there? We'll pick up number 5 tomorrow, and have a nice day.